Good day, everyone. So, we are here to present our final output for the first semester, entitled Eggplant Skin as a Natural pH Indicator. So, let us meet our proponent, Von Ferranculio, Joyce Bacolo, and Angelica Gunyo. So, let's have a short background check regarding our experiment today. A solution is a mixture of two or more substances that has the same composition throughout. Solutions can either be acidic, basic, or neutral depending on their identity. To identify which solutions are acidic and which solutions are basic, along with the relative strength of each solution, a pH scale is used. pH is the measure of the relative amount of free hydrogen and hydroxyl ions in the water. It is used to measure the acidity or basicity of a substance. The range goes from 0 to 14, with 7 being neutral. A solution with a pH less than 7 is acidic, whereas a solution with pH greater than 7 is basic. The acidity of a sample means that there is a higher number of hydrogen ions, which it can be detonate in case of reaction, and basicity means that there is a lower number of hydrogen ions. A change in the pH level of a solution represents a change in the concentration of the sample by a factor of 10. Thus, a small change in pH level, even by a decimal point, changes the concentration of the solution. This is why identifying the acidic or basic nature of a liquid is important in determining the uses of the liquid. The most common method used to determine the pH of a solution is through the use of litmus paper. However, there is another method that can be used to distinguish between acidic and basic mixtures. It is through the use of plant-based indicators. An indicator is a dye that changes into a different color depending on whether the solution is an acid or a base. Each indicator dye has one color in an acidic mixture and a different color in a basic mixture. This acid-base indicator can be made from different plants such as violet eggplant, purple kamote, blueberries, and red cabbage. These plant materials contain anthocyanin, which is responsible for producing a specific color in solutions of different acidity or basicity. In this specific experiment, we will be using eggplant peels specifically in making the pH indicator. This experiment aims to create a pH indicator using eggplant peels. The next is to identify the nature of certain household items, whether it is acidic or basic. And lastly, to prove that eggplant can be an alternative pH indicator to red cabbage.
Okay, so let us now move on to the experiment itself. First, let's have a quick run through on the materials and samples used in performing the experiment. For the materials, skin from 2 eggplants were used, water, clear plastic cups, heat-resistant container, a dropper, white paper, and a 10 ml syringe without the needle. As for the samples, we used 1 teaspoon of water, 1/2 teaspoon of baking soda, 2 tablespoons of vinegar, 5 drops of liquid bleach, and 5 drops of lemon juice. As for the experiment itself, let us watch this short video.
Hi guys, I am Angelica Gunyo.
I'm Joyce Bacalo. We're from BSMT 151 Section 26.
And for today's video, we are going to try dried eggplant peels as our natural pH indicator. But first, let us discuss what are the materials needed in this experiment. First, of course, are dried eggplant peels,
Hot water, measuring tools,
And of course, our heat-resistant container.
1/2 teaspoon of baking soda,
5 drops of bleach,
5 drops of calamansi juice,
2 tablespoons of vinegar.
and 1 teaspoon of water.
But first, let us set aside these 5 samples and let us soak the dried eggplant peels into 250 ml of hot water.
Yes, we will soak it in hot water for 5 minutes. Stay put and we'll be back. So, welcome back after soaking the dried eggplant peels for 5 minutes. It's clear that the water has turned into reddish purple.
So what are you waiting for? Let's add 10 ml of our natural pH indicator to each of our sample.
Let's begin with the first sample, which is the baking soda. We'll add some more. Oh, look, Angelica! It turned into dark greenish color.
Oh, that's cool. Let me try the second sample. So guys, I am going to add 10 ml of our natural pH indicator with 5 drops of bleach. So let's add some more. So as we can see, it also changed its color and it turned into pale yellow.
Wow! I'm so excited to try the third one. I'll now put 10 ml of our natural pH indicator into 5 drops of calamansi juice. Mmm! In this sample, the color turned into pinkish red.
So for the fourth sample, which is the vinegar, let's all see what color it would turn to. So obviously, it turned pink.
Okay, finally, let's try adding 10 ml of natural pH indicator to this water. Let's try to add some more. In this case, I think it turned into a bluish purple.
So finally, the experiment is done and we can now distinguish the pH level of our sample using dried eggplant peels as our natural pH indicator.
Thank you for watching our experiment, guys. Bye!
Let us now move on to the results and discussion. So after adding the indicator made from boiled eggplant skin to the samples, we observed an immediate change in the color of the solutions. The table presented shows the different samples used, the respective amounts, the pH indicator used in the samples, the colors observed when the indicator was added, and their respective pH levels. The samples are also arranged from lowest to highest pH value. Lemon, which according to our research is the most acidic sample with a pH ranging from 2 to 3, exhibited a pinkish red color when the indicator was added. Vinegar, which is typically a mildly acidic with a pH of 3 to 4, exhibited a pale pink color. Water, on the other hand, is a generally neutral solution with a pH of 7 and exhibited a bluish purple color. Next is baking soda. a typically basic solution with a pH of around 8 to 10. It changed into a dark greenish color after the indicator was added. Finally, liquid bleach, which has a pH level ranging from 11 to 13 and is the most basic among our four chosen samples, exhibited a pale yellow color after the indicator was added. Based on the data gathered from the experiment, we can now generalize what color the solutions will exhibit if the indicator is added to an acidic, neutral, or basic solution. According to the table, acidic samples such as lemon and vinegar typically exhibit a red to pinkish color when mixed with the indicator, while basic samples such as baking soda and liquid bleach typically exhibit green to yellowish colors. As for neutral samples, water was observed to have a bluish purple color when mixed with the indicator. Using eggplant skin as the indicator, the colors exhibited by the acidic, neutral, and basic samples were similar to the colors these same samples would exhibit if red cabbage was used instead of eggplants as the pH indicator.
We can therefore say that eggplant can be a reliable alternative to red cabbage in making a pH indicator. This is because eggplants, similar to red cabbage, contain an organic molecule called anthocyanin, which is primarily composed of an organic compound called flavin. This compound gives eggplant its distinct violet color. Flavin is a water-soluble pigment that can also be found in apple skins, plums, and grapes. Flavin changes color depending on the acidity or basicity of a solution. Very acidic solutions turn the indicator a red color. Neutral solutions turn the indicator a bluish-purple color. And basic solutions turn the indicator a greenish-yellow color. Although red cabbage is the generally accepted material used in making a pH indicator, we chose eggplant peels instead since they are cheaper and more accessible. And since eggplants also contain flavin, then the results would still be the same regardless of which of the two we use. So in conclusion, boiled eggplant skin is proven to be reliable and can indeed be used as an alternative pH indicator. This is because, like red cabbage, eggplants also contain the organic molecule anthocyanin, which is composed of flavin, the compound necessary for identifying the pH level of substances. This experiment also allowed us to identify which samples were acidic, basic, and neutral. It also gave us students a gist on how pH testing works, as well as how to determine the pH of certain substances. So this is the end of our presentation. Thank you for listening.